Hello and welcome to this PyCon workshop. Sebastian will present a modern Python developer's toolkit. Sebastian is a consultant and a trainer based in Poland. Hello, Sebastian.
Hello.
Hi. He started his career in programming at CERN, and today he will teach us about how to set up a Python project from scratch, including dependency management tests and everything else you might need. The workshop is divided into two parts and has been pre-recorded. The first half is approximately 25 minutes and the second half just under 50. Sebastian will be available on Slack throughout, and there will also be a short break after the first video for questions and comments. So let's get started. Sorry about that. I will play the stream again. One moment, please.
Hi, if you're watching this, it means that I'm already dead and I was killed by a giant... Wait, that's not the right script. Here it is. Hi there, and welcome to PyCon Sweden tutorial. I'm excited to be here, even though this is just my home office, and I hope you're excited too. So in this tutorial, I want to give you an overview of some common tools that you can use when you're programming in Python. You will find the materials at pycon.switowski.com. As you can see, we have a lot of sections here, but we only have an hour and a half, so I won't be able to show all of that. So we will skip setting up the VS Code and the deployment. But if you're interested, I have a video from PyCon US that includes those two sections, so feel free to watch it later. What we will talk about is how to manage different Python versions and dependencies on your computer. I will show you some cool tools that you can use, and after that, we are going to have a few exercises where you can practice using them. So this first section should take around 25 minutes, and then you will have around 5 minutes to practice and ask me some questions or take a short break. Next, we are going to talk about how to structure your project and how to use a cookie cutter to generate a scaffolding for your project. Then I will talk about code style. I will explain you what a PEP8 and PEP257 are, and I will show you some code formatters and linters that you can use to make sure your code is compliant with the best practices. Next, we'll talk about a replacement for a standard Python REPL. And finally, I will show you how to use PyTest for writing tests and how to use Sphinx to generate the documentation. After that, I have another exercise in the form of a mini project where you will have a chance to build a to-do web application using Flask framework. Since it takes quite a bit of time to build it, and not all of you know Flask or want to use Flask, I will leave it to you as a homework, and I will point you to a video with the solution. And at the end, we should have around 5 to 10 minutes left for any questions that you might have. But since those videos are pre-recorded, I will also try to answer all the questions in a chat during the tutorial, if there is a chat, of course. As for the requirements to follow this course, since I won't talk about VS Code and Docker, you don't really need them. The only thing that you need is a Python version of 3.6 or higher. If you're using an older version, first of all, please stop because they are no longer supported. And some things like F strings might not work, but otherwise you should be good. I'm using a Mac OS, so if you're on Mac, it should be easy for you to follow along. And all the tools should also be available on Linux. As for Windows, there are some differences that I will try to point out as we go. They're also pointed in this documentation, so you should look for a small Windows icon. And that's pretty much it. Oh, I forgot to introduce myself. Hi, so my name is Sebastian Witowski, and I'm a Python consultant, freelancer, and trainer. I mostly build web applications using Django and other frameworks. So if you need an application build, you can contact me through my website, switowski.com. Also, if you have any questions from this talk that I didn't manage to answer, feel free to send me an email or find me on Twitter or LinkedIn. And I think we are ready to start. So let's begin by talking about Python and Python packages. In this part, we are going to see how to install different versions of Python and how to easily switch between them, but also how to isolate dependencies for your project and why do you care about isolating them. Sooner or later, you'll need to install a different version of Python on your computer. Probably sooner than later. For example, if you're using a MacBook, then you'll have Python 2 installed by default. And you might be thinking, well, that's an outdated version, so why don't I just update it to Python 3? And this is a terrible idea because you have some software on your computer that relies on this old version of Python. So if you change it, you'll probably break some stuff on your computer. And even if by chance you have Python 3 installed globally on your computer, it's probably not the latest version, and you shouldn't rely on a system-wide Python. Things get even more complicated if you're working on multiple Python projects and you want to have different Python 3 versions installed at the same time. For example, if you're writing a Python library, then you probably need to test it in at least a few recent versions of Python. So let's say Python 3.6, 7, 8, and maybe 3.9. And you need to have an easy way to switch between those versions. You can install each of them with a separate prefix, but that's a bit cumbersome, and there's actually a much easier way to handle this problem. In this part of the tutorial, I'm going to show you how to use pyenv to install multiple versions of Python and how you can easily switch between them. The easiest way to install pyenv is to use pyenv installer script. It will install not only pyenv, but a few additional plugins like pyenv doctor to verify that the installation is fine, pyenv virtual environment, which is really nice because it's a plugin to manage virtual environments that we'll be talking about next, and a few more. So if we go to pyenv installer, you can see that the recommended version is to run this curl command. If you don't trust running scripts from the internet, which in general you shouldn't trust them, you can also use Homebrew or simply clone the repository as explained in the installation section. But I'm going to choose the easy way. I open the terminal, paste it here, run it. At the end of the installation, you will see some instructions on how to add some code to your bash rc file, or if you're using Z shell or fish, it's going to be slightly different. But it's important to pay attention to this message. So let's copy those lines and add it to our bash rc file. And finally, we have to restart the terminal. To check that everything worked fine, I'm just gonna run pyenv command. And it doesn't work because I'm using zshell, not bash. So let's modify the zshell rc file. And one more try. Great. If you see a list of commands here, it means that the pyenv was successfully installed. Once you have installed pyenv, make sure to check the dependencies section on GitHub. For macOS, it mentions a few packages that are optional but recommended. So if you notice that you have some problems using pyenv, make sure to install them. We also have a list of dependencies for other operating systems. And if you want to use pyenv on Windows, check out the pyenv win package. It doesn't have all the features of pyenv, but it has the essential ones, so you will be able to install different versions of Python and switch between them without a hassle. Also, if you are on macOS Mojave, then there is this GitHub issue that explains that you have to add additional SDK headers. If you're on version above Mojave, like Catalina, then you don't need this step. Let's try to install a new version of Python using pyenv. To see the list of available versions, we need to run pyenv install -- list. Here you can see all the versions that pyenv can install for us. At the top, you have the standard Python versions. Then you have Anaconda, Miniconda, you even have PyPy, and some other stuff like Stackless. So let's try to install the most up-to-date version of Python, so 3.8.2. When we talked about the dependencies, I showed you that for macOS, some dependencies are optional. And here, since we didn't have OpenSSL, pyenv is installing it for us. Done. That took around 10 minutes. So I'm really happy that I didn't try to do live coding and I can just fast forward it. So now if we do pyenv versions, we can see that we have the system version of Python and the 3.8.2 that we just installed. Let's add another version. If you don't have OpenSSL, readline, or zlib dependencies, pyenv will download them for each new version of Python that you try to install. So normally I would install those dependencies using Homebrew. If we check installed version, you can see we have two different Python versions installed. If I try to run any Python command, you can see that I'm still using the built-in Python version. So if we want to switch which version of Python we are using, we need to use pyenv global command. If you just run pyenv global, it's going to tell you which Python you are using. If you run pyenv global with a version number, you will switch your Python to this version. So now if I try to run Python command, you can see that it has not changed. So if this happens to you, you need to run pyenv rehash. I forgot to mention this, but you need to run Python rehash after you install a new Python version. So pyenv will set up everything for you. So let's try to run Python command again. And voila, now we are using the latest version of Python. If I want to switch to a different version, all I have to do is to run pyenv global and the different version. And that's it. Every Python version is nicely isolated from each other, and you don't have to worry that you will mess up something if you try to install another one. So now we know how we can change the global Python version on our computer. But another cool feature of pyenv is that you can set a Python version for a specific directory and all its subdirectories. It's a useful feature if you're working on a project that requires a different Python version. For example, you have some legacy code that is still using Python 2, and you only want to use Python 2 if you are in the specific directory. So instead of switching the global version back and forth, all you have to do is to run pyenv local, and this will create a Python version file. Pyenv will always look for this file in the current directory, and if it can find it, then it's going to use it to determine which version of Python you want to use. So let's see this in action. As you can see, I'm using Python 3.8 globally. And let's say I have a project that requires an older version of Python. So if I want to use Python 3.7 only in this folder, all I have to do is to run pyenv local and a Python version. This will create Python version file, and inside of it you can see which version of Python we want to use. So if we run Python version command, you can see that we are using Python 3.7. And if we go outside of this directory, you can see that globally we are still using Python 3.8. So this is a really nice feature of pyenv, especially if you're working on different projects that require different Python versions. And the final feature of pyenv that I want to show you is how you can change Python version for only a specific terminal session. So for example, if you want to test something in, let's say, Python 2, you don't have to change the local or global Python version. All you have to do is to run pyenv shell command and provide it with the version number. So let's say I'm globally using Python 3.8, but for some reason I want to test something in Python 2. On my computer, I still have Python 2 installed as a system Python, so I can use that. This command starts another shell session in our terminal. So if I run Python version, you can see that I'm using Python 2. And we even have the warning, Python 2.7 is not recommended. If you're wondering how does pyenv works and how does it install different Python versions without messing up anything on your computer, all it does is it creates a directory of shims and puts some binary files like Python, PEP, Python3 there. And then it inserts this directory at the beginning of your path variable. So each time you run command like Python or PEP, your computer, instead of using the system-wide commands, will pick up the binaries from this shim directory. And those binaries are not even real Python commands. Those are just pyenv scripts that will determine what's the current version of Python that you want to use and call binaries from this version of Python. And this whole idea of creating a shim directory and adding it at the beginning of the path variable is not new. If you're using other programming languages, then you probably already know rbenv, nodenv, or goenv that do exactly the same thing, but for different programming languages. If you're programming in multiple languages, check out the ASDF VM. This is one tool to manage different versions of different programming languages. So if you use it, you don't have to install separately pyenv, nodenv, rbenv. With pyenv, we solved one problem, how we can easily switch between different versions of Python. But even if you're using the same version of Python all the time, you will have another problem, managing Python dependencies. So Python has one big problem. You cannot have multiple versions of the same package installed at the same time on your computer. Since every package goes to the same directory, you can't have Django 2 and, let's say, Django 3 installed at the same time. Each time you run pip install Django, pip will check if Django is already installed on your computer. If it's not, it's going to install the latest version. You can also specify which version you want to have. So for example, if you want to have Django version 2, you will do pip install Django == 2, and then pip will first check if you have this version of Django on your computer. If you don't have it, it's okay. Pip is going to install it. If you have a different version of Django, let's say version 3, pip will first uninstall it and then install version 2 instead. Great, so now you have version 2, but if you switch to another project that is using version 3, it will stop working. There is no longer Django 3 on your computer. So you can run pip install Django == 3, which will uninstall version 2 of Django. So now each time you switch a project, you will be uninstalling some dependencies and installing different versions. And the more projects you have, the more annoying this thing can be. To solve this problem, we can use virtual environments. A virtual environment will prepend a folder with some binaries to your path variable. So each time you run Python command, you will automatically use Python and packages from this folder. And if you run pip install, you will install packages not globally, but inside this virtual environment. With virtual environments, the main idea is that you should use separate virtual env for each of your Python project. So that way you won't mix dependencies. If you're using Python 3.3 or above, then you don't have to install anything to use virtual env. there is already a built-in module called pyenv that we can use to create virtual environments. To create a new virtual environment, run python -m-pyenv and then specify the name of the virtual environment. This will create a directory named in the same way as you named your virtual environment. And inside this directory, you can see there is a bunch of folders and files. The only one that we are actually interested in is inside the bin folder, and it's called activate. When we run it, this will activate this virtual environment. You can see that now we have the name of the virtual environment displayed in the terminal. So it's a good way to see if we are currently using a virtual environment or not. Right now we are inside an isolated environment. If we install some packages with pip, they won't be installed globally, they will be installed in this folder. Let's try it. Let's say we want to install Flask. And if we do pip freeze to see the list of installed packages, you can see that we have Flask and its dependencies here. To stop using this virtual environment, we just have to run the activate command. Now we are not using any virtual environment, so if we try to list the pip packages, you see that there are no global pip packages. If we try to run Flask, we'll get a message that Flask is not installed. Let's say we have another project where we are using a different version of Flask. So let's create another virtual environment. And now let's install previous version of Flask. As you can see here, we are using a different Flask version. And that's pretty much all you need to know about virtual environments. Each time you start a new project, create a new environment, use pip to install packages inside of it. And when you stop working on this project or you want to switch to a different one, just deactivate the environment. Apart from the built-in pyenv module, there are some other tools that will make using virtual environments slightly easier. For example, if you install pyenv using this pyenv installer, then you also have installed the pyenv virtual env plugin, so you can use it to create and manage virtual environments. The main advantage here is that you don't have to remember in which folder you created which virtual environment. Pyenv virtual env will take care of it for you. To create a new virtual environment, run pyenv virtual env, then specify the Python version and the name of the environment. You can see that no new folder was created. This is because pyenv is storing virtual environments in a separate directory. To see the list of available virtual environments, run pyenv virtual envs command. To activate one of them, run pyenv activate and the name of the environment. And to deactivate it, just run pyenv deactivate. Apart from pyenv virtual env, there is also virtual env wrapper, which is a quite old but still very popular virtual environment management tool. It has a very similar set of functionality, but it's mostly using different commands. And since virtual env wrapper doesn't work with the fish shell, I found that there is a tool called virtual fish that you can use instead. It has the same set of functionality as virtual wrapper, but the commands are even shorter. You may have heard about PEP8, and if you're already using it, I'm not going to suggest you to change it, but if you're looking to start using virtual environments, I would not recommend using PEP8. There are some issues with the maintenance of this project, and since there are many good alternatives, I suggest that you take a look at some other project. One of those projects can be Poetry, which is a whole new way to manage Python projects. You can use it to generate a scaffolding for your project, to manage dependencies, prepare it to be published on PyPI, etc. So if you're looking for one comprehensive way to manage your Python projects, you can check it out. And finally, if you come from data science part of Python community, then you are probably familiar with Anaconda. It makes installing new Python versions and packages much easier. It automatically creates virtual environments and installs all dependencies inside of it. When you use Conda, you don't have to worry about the missing dependencies. They will usually be bundled together with the packages. The main difference between pip and Anaconda is that Anaconda doesn't install packages directly from PyPI. It installs binaries, which means that someone first has to build this binary and publish it to Anaconda repository. Most of the time, that won't be a problem. If you stick to popular packages, most of them are already available. But if you want to install a new package or a package that you just created, then, well, you can't. If you're using Windows, Anaconda can make your life much easier. So if you're having problems using PEP, it's fine to use Anaconda, but I still suggest you to learn how to manage your dependencies with virtual environments and PEP. Even though it's more difficult than using Conda, that's what most Python developers are doing, and it will give you much more flexibility in the long run. So we solved the problem of separating dependencies between different projects. However, sometimes there might be a situation where you want to use the same tool in all of your projects. For example, if you want to use Black, a code formatter, or Flake8, a linter, you don't want to go to every virtual environment and install it there, because it's a lot of work. But you shouldn't also install it globally, because the more packages you install globally, the bigger the chance that some of their dependencies will conflict with each other, and you will again end up in this situation that one package is uninstalling others. To solve this problem, you can install PEP8. PEP8 installs PEP packages in separate environments, but at the same time, those packages act as if they are installed globally, so you don't have to activate virtual environment to run them. We can install PEP8 with pip or brew if you're on Mac. After the installation, make sure that the path variable is updated by running pip8 ensure path command. Now we can list all the packages by doing pip8 list and install a new one by doing pip8 install and a package name. Let's check the list of pip8 packages again. Here you can see we have Black, and it's exposing two commands, Black and BlackD. And this is the location where pip8 is creating its virtual environments. So now if we do pip freeze, you can see that Black is not installed globally. But if we try to run it, it works. You can also use pip8 run command to run a command from pip package in a temporary virtual environment that will be deleted after the command exits. So let's say we want to run Flake8 just once. We don't really want to install it. And as you can see, even though we run Flake8, it has not been installed. If you followed the first part of the workshop where we were setting up VS Code, you remember how we installed Flake8. By default, VS Code was installing Flake8 globally, and I told you that it's not a good idea to do this. So I'm going to show you how to configure VS Code to use Flake8 from pip8. So first, let's install Flake8 using pip8. Now we need to get the path to the Flake8 binary. So let's go here. And as you can see, Flake8 is here. So let's copy this path. Let's go to VS Code, open the settings that you can find here, and search for Flake8. You will see that there is path to Flake8, and by default, it's just Flake8 binary. What you need to do is to replace this value with the full path to the Flake8 from the pip8. So now let's save it and we can run it. And the path is invalid. Well, let's see what happened. Okay, so I know what's the problem. This is not really a binary, it's a folder. So yeah, we can go inside and then there is bin folder and there we have the binary. So we have to use this full path instead. Save it, we close the settings, and yay, we have a linter. We can see it complaining, so everything is fine. We covered a lot of ground here, so if some of those tools are new for you, I have prepared a short exercise that you can use to practice using them. Open exercise 1 and follow the instructions there. If you already know pyenv, pip8, and you're already using virtual environments, you can skip this exercise. But if one of those tools are new for you, I suggest that you follow them. And if you have any questions, take notes, and you can ask your questions during the interactive session at PyCon.
Thank you, Sebastian. That was really interesting.
Thank you.
Let's see, do we have any questions here? I think you got a question about pyenv and pipenv, but you answered that one already.
Yeah, I try to answer both on YouTube and on the Slack. There were quite a few questions. I don't know if there is any point in rereading them because people can see them on the Slack.
Yeah, but let's take a break until 11:05. We can continue with the second video then.
Yeah, I will be still at the Slack, so if people have some questions, I will be answering right away.
Yes, and also the YouTube chat.
Yeah, both.
Yeah, great. See you later. Right. Are we ready for the second video?
Yep.
Yeah?
Yep.
Anything you want to say before?
Not really. I mean, enjoy.
Yeah? Great. I'll see you in about 50 minutes then.
Yep.
Yeah.
See you there.
See you.
I hope the exercise wasn't too difficult and you're not too bored. Let's switch gears and talk about something else than tools. A very common question that I hear is how to properly structure a Python project. And I don't have one correct answer for this. Python doesn't enforce any structure. So as long as you know what you're doing, you can organize your project however you like. From the tools and frameworks that I know, only Django will try to put some scaffolding for you, but you can always ignore it and move stuff around. When you first think about the structure of your project, it might not sound complicated. And usually it won't be. But if you're not careful, you will probably hit one of the two common problems. First, the file that you try to import is not on the import path, and this usually manifests through a module not found error. Or you are going to hit some circular import errors, usually resulting in import error. If you have never encountered these problems, then probably me just talking about them is going to be boring for you. So I suggest that you read the rest of this chapter on your own. And if you ever have some problems with the circular import errors or module not found errors, I try to describe the possible solutions and also linked to some explanations on Stack Overflow. In the meantime, I would like to show you how we can structure our projects to avoid those problems, and I would like to show you a tool that can help us with that. Every Python project is different, but quite often they share some common elements. Writing a website in Django is no longer an exciting adventure into the world of web frameworks. It's more likely a mundane creating the same HTML templates, connecting them to URLs, and writing some views that are extracting information from the database. And since thousands of developers wrote a Django or Flask application or published a Python package before you, some people came up with an idea to extract common parts of those applications and create a reusable scaffoldings. And that's how the cookiecutter project was born. With cookiecutter, you can create templates and then use those templates to generate scaffoldings for your projects. For example, if you're writing a lot of Django websites, you might notice that each of them has a similar structure. So you might sit down and extract the similar parts into a template, put some placeholders, for example, a website name, author, date, or the license. And then when you need to create another website, you will use this template to generate most of the code. In this workshop, we won't be writing a cookiecutter template, but we'll be using one. So how to use it? If you go to the cookiecutter website, you can see that down there is a list of different popular cookiecutter templates. For example, if you want to create a Python package, you can use cookiecutter py package. If you want to write a Flask website, there are a few Flask skeletons. The same for Django. It's somewhere on this list. Here. There are plenty of different Django templates, even something for Pyramid. And you even have templates for different languages. There are templates for C, C++. So let's say we want to write a Python package using the cookiecutter py package template. First, we need to install cookiecutter. Notice that I'm using pip8. Cookiecutter is a tool that I want to use across different projects. So there is no point in storing it in the same virtual environment as my project. I want it to be available globally on my computer. Next, we run cookiecutter command and we paste the URL to the GitHub repository with the template. So in this case, I want to use cookiecutter py package. Press enter, and then cookiecutter is going to ask you a couple of questions. The value in the brackets is the default value that is going to be used if you don't provide a different one. Some of the questions are important, some of them are not. For example, here, if you provide your full name, it's going to be used mostly in the documentation or in the license files. But later on, you will see some questions that are actually quite important. So let's fill in some information. Here, I don't want to change the default value, so I'm just going to press enter. Now we got to the point where the questions are actually important. Here, we need to decide if we want to use PyTest as our testing framework or if we want to use something else, like maybe the built-in unit test. I want to use PyTest, so I select yes. Here we can choose if you want to do PyPI deployment with Travis. I don't want to use it, so I put no. I have no idea what's PyUp batch, so I'm gonna go with the default no. Here you can select a command line interface. You can either use a popular click library, the built-in argparse, or you can choose to not use the command line interface. Depending on your answer here, cookiecutter will either add or remove some files that would normally be a boilerplate for your CLI. So let's say I want to use click, so I select one. I have no idea what's this author file, so I'm gonna say no. And now I can select the license. Let's go with the default one. If we look inside the current directory, you can see that cookiecutter has created a directory for us. If we go inside, you will see that there are a lot of files. Let's use tree command. I can't use tree. The amount of files can be quite overwhelming, especially if all you want to do is to create a very simple Python package, but you can ignore most of them. For example, contributing will only contain some information for the contributors to your project. History is a place where you can store changelog of your project. Some of the files that you should care about are, for example, the make file. If you have never used make files before and you think they are scary, you can ignore them for now, but they can be a really good place to store your scripts. For example, here you can see we have some commands to clean up compiled files, to lint our files, to run tests, to generate the documentation or the code coverage, and finally to install our package. Then there is docs directory, and this is where the documentation for your package will live. This cookiecutter template is using Sphinx to manage documentation, and I will talk more about Sphinx later in the workshop, so we can skip this folder for now. The My Awesome Python package directory is a place where the code of your Python package will live. The name of this folder depends on what name you give to your package. So as you can see, cookiecutter is able to generate some files or folders in a dynamic way, depending on what answers you provide. Next, we have requirements.dev.txt file. This file contains a list of Python packages that you will need for development. As you can see, we have flake8 for linting, pytest for running tests. So those are not the packages that the end user of your package will use. The end user packages are, in this case, listed in setup.py. And in some other projects, you might find them in file called requirements.txt. Setup.py is probably the most complicated file in this whole directory. It contains a bunch of settings that will let you publish your package on PyPI or install it with pip. The good news is it's already set up for you, so you don't really have to touch it. And as you can see, here we have the end user requirements of our package. And in this case, it's just a click package for the command line interface. There is also setup.cfg file that contains settings for various tools that you will be using during development. So as you can see, there are settings for flake8, for pytest. This file is already pre-configured for you, so you can also ignore it. If you want to start building a Python package now, all you have to do is go inside the myAwesomePython package, open the myAwesomePythonPackage.py file, and add some modules and functions here. If you want to use a CLI, you also want to modify the CLI.py file. As you can see, there is already some code here that can help you start. And then when your package is ready, you will see that inside the make file, there is release command that will build and publish your package on PyPI. One advantage of using cookiecutter is that those templates will often provide you with some additional tools that might help you with the development process. And the most popular cookiecutter templates are a collaborative effort of many Python programmers. So they will usually contain tools that have been used and tested by many other developers, not some shiny new toys found yesterday on Hacker News. For example, the PyPackage cookiecutter that we just used installed Tox. That is a very useful tool to run tests under different Python versions. And since you are writing a Python package, you probably want to test it under at least a few recent Python versions. And it also installs Sphinx, which is probably the most popular tool for writing documentation in Python. And again, since you're writing a Python package, you probably want to document how to use it. Some templates will be more opinionated and they will install more tools. Some of them will be more bare bone. In the end, it's up to you to decide which template you want to use and if you actually want to use all its features. If you think that the template you found is too complicated, just go to the cookiecutter website and search for another one. For example, if we want to build a Flask website, just search for Flask and see what's there. Here you can see we have a Flask template with Bootstrap. Let's see how it looks like. Okay, so as you can see, we'll get a pretty basic Bootstrap website with some registration and login forms and SQL Alchemy. If you feel like you don't actually need all this stuff, all you have to do is go back and search for another Flask template. Maybe you want a very bare-bone Flask application, and here you can see there is a Flask minimal template that might be more suitable for you. So as I said, it's worth checking out at least a few different templates, comparing what they have to offer. And if you don't understand how something works, either check the documentation of the template if it's mentioned there, or just remove that code. Apart from deciding how to structure your project, there are some other important decisions that you have to make. And I'm not talking about how to architecture your application, whether to use a microservices or build a monolith, which database engine to use, or how are you going to deploy and scale your application. Now, before we get to that, there is something else that you need to sort out, especially if you're working with other developers. You have to decide on a code style. Things like tabs or spaces, how many characters per line, whether you should use absolute or relative import. And honestly, I have seen people fighting more about the code style than the overall architecture of the project. And I understand it. I have my own preferred way of writing code. But if you're working with others, sometimes you have to compromise. So that's why we have PEP8. It's a style guide for Python that documents how you should write your code. And then we have PEP257, which is a style guide for the documentation. Those two documents give us a very solid foundation on how to write and document our code. And even if it's the first time you hear those two names, if you're using the auto-formatting feature of your code editor, then your code is probably already compatible with those rules. PEP8 documents, for example, how many spaces you should use for the indentation, how to indent the closing parenthesis or the bracket, what's the recommended line length, or how to sort import statements. And unless you have a very good excuse, you should follow those rules. The most common exception nowadays is the line length. Since our screens are getting bigger and bigger, increasing the limit beyond the 79 characters makes a lot of sense. But even with PEP8, there is still some room to argue. Like, how do you split functions that have multiple lines? How many spaces you should use for the hanging parentheses and stuff like that. Discussions about those small details can waste a lot of time during the code reviews. And to be honest, there is no one perfect way how you should write your code. So instead of focusing on those small details, it's easier to use an automatic tool that will fix those small problems for you and focus your code reviews on things that actually matter. One of those tools is Black. Black will take your files and format them according to the PEP8 and PEP257 rules, with some additional rules on top of that. Black offers almost no customization. The only setting that you should be able to change is the line length if you don't like the default 88 characters. There are some options like skip string normalization that stops Black from turning your single quotes to double quotes, but according to the documentation, you should not use it. Black is opinionated. Some people like it that way, some people don't. I work with people who wouldn't merge a pull request because they don't like the code formatting. So Black takes those silly discussions away and helps you focus on what actually matters. So if you ask me, I'm going to stick with it. And unless you like fighting with people about code style, you should probably also use Black too. Okay, so let's finally see Black in action. First, we need to install it. I suggest that you use pipx since you want to use Black globally in all your projects. Yeah, seems like I already installed it before. Yeah, as you can see, we have two commands, Black and BlackD. I think this is to start a daemon. So now, if we have a piece of code that is ugly, and this code is ugly on purpose, I promise you, I don't write code like that. It's okay to hire me. Now, if we run Black on this file, you will see that it was reformatted, and we even get some nice emojis. So let's see how it looks after the reformatting. As you can see, the imports are nicely aligned. All the redundant white spaces are removed. The list is now on one line. The dictionary has proper spacing between the key and the value. So this code looks much nicer. And if we try to run Black again, you'll see that this time there was nothing to change. And that's how you would use Black. You can run it on a folder with your project. You can plug it to some continuous integration tool. You can use tool like pre-commit to run it each time you create a new commit in Git. Or you can just run it by hand as I just did. Another set of tools that can help you write better Python code are static code analyzers. One of the tools that I'm using all the time is called Flake8. Flake8 is a linter, so unlike Black, it won't change your code, but it will give you some hints about possible problems in your code. And Flake8 actually combines 3 different projects. PyFlakes, which gives you warnings about unused modules, undefined variables, and stuff like that. PyCodeStyle, which gives you warnings about PEP8 violations, and McCabe, which is disabled by default. But if you enable it, it will give you warnings about cyclomatic complexity of your functions, which basically means how complicated your functions are. Flake8 integrates really nicely with VS Code, so let's take a look. As you can see, this is our ugly.py file with a lot of ugly Python code, and all the red squiggly underlines are errors reported by Flake8. So here on the first line, we are importing a bunch of functions, but we are not using it. Here it's complaining that we don't have 2 blank lines. Here that we are assigning a local variable mylist and we are not using it. Same with the dictionary. Here it's missing some white spaces and stuff like that. You can also see all the problems in the problems tab. As you can see, there is a lot of things here. And if for some reason Flake8 is not working for you and you want to enable it, you can open the command palette, type select linter, and then from the list here, select Flake8. You can also experiment with the other linters, and I will talk about them in a few minutes. One of the reasons why Flake8 is so popular is because it has a massive catalog of plugins that you can use to customize it. Some of them will modify the default behavior of Flake8, and others will give you additional options that you can use while running Flake8. You can find a list of most popular plugins on the awesome Flake8 extension website. It's a GitHub repository with a huge list of different extensions. I have listed here some that I found quite useful. And even if you're using Flake8, I suggest that you take a look at this list because when I was preparing it, I found a lot of useful stuff that I wasn't aware of. Some of those extensions will add additional checks, for example, to make sure that you're not overwriting the built-in variables and that you don't make some silly mistakes. Stuff like Flake8 comprehensions will suggest you places where you can use list, set, or dictionary comprehensions over a for loop. There is also Flake8 docstrings, which will enforce PEP257, and many more plugins like that. If you're using a lot of Flake8 plugins between multiple projects, check out the FlakeHell or Talks. They will both let you install and configure all Flake8 plugins by modifying one configuration file. So you don't have to go to each of your projects and manually do pip install Flake8, this extension and that extension. It's a useful tool. In case you haven't yet installed Flake8, this is how you can do this. I suggest that you use PEP8. So Flake8 is available globally, but it's still separated from the other dependencies that you have. And if you use PEP8, and you want to install Flake8 plugins to the same virtual environment where the Flake8 lives, you will have to use PEP8 inject function. And if you want to run Flake8 on your folder instead of using VS Code, just run this command. Flake8 and Black are the 2 tools that I'm using everywhere where I can. But there are some other static code analyzers. Another popular linter is a pylint. It has some overlap with Flake8, but you can safely use both of them at the same time. Just keep in mind that pylint is much more strict than Flake8. It will complain if you have too few public methods, too many local variables, or classes with no init method. It's much easier to write code that will make Flake8 happy than it is to write pylint compatible code. So try running pylint on your existing project and see if you like it. Next tool is Bandit. Bandit is designed to find common security issues in your Python code. If you run it out of the box, it will give you plenty of false positives. For example, it will complain about using assert statements in your PyTest files. But if you spend some time and configure it, it will print some possibly useful information about insecure usage of some modules, possible SQL injection points, silently ignoring exceptions and stuff like that. If you're a beginner, Bandit can be a good tool that will help review your code. PyDocStyle is a tool that will make sure that your documentation is written according to the PEP257 rules. Just keep in mind that it will complain about missing documentation of every function or module that you didn't bother to write. Then there's Vulture that will help you find unused code, and we make Python style guide, which is another strict linter that combines Flake 8, bunch of Flake 8 extensions, and some custom rules on top of that. It's very strict, so it might be too much for your project, but maybe you will actually like it. And finally, there is Prospector, which is like Flake 8, but instead of PyFlake, it's using PyLint. So it's a combination of PyLint, PyCodeStyle, and McCabe. And my final tip here is that you can automate most of those plugins by using the pre-commit tool. So pre-commit lets you plug linters, formatters, and static code analyzers as Git hooks, and they will be automatically run when you create a commit. Check out this link to see how to set up Black and Flake 8 as pre-commit hooks. Another tool that you will use very often if you write Python code is the interactive Python shell, or the read eval print loop. It's this type of shell that you get when you type Python in your command line interface, and here you can execute some Python code. It's nice to have the Python REPL so you can test your code interactively, but the basic Python REPL is, well, basic, and in the long run it's not very convenient to use. There are a few different ones. The most popular one is IPython. It's the same REPL that runs behind the Jupyter notebooks, so even if you never used IPython directly, you might be familiar with it. We can install IPython using pip or pipx. Again, I recommend pipx since this is a tool that you will share between all your projects. The only difference for you now is that if you want to start an interactive session, you just have to type IPython instead of Python. Some of the best features of IPython are the tab completion. If you press tab in a standard Python shell, well, it's gonna insert tab. If you press tab in IPython, it's gonna show you a list of possible auto-completion items, just like in your code editor. We also get syntax highlighting, better error messages. If you start writing a function or a loop, IPython will detect that and automatically indent the next line if you press enter. And finally, my favorite feature of IPython, the dynamic object introspection. You can see the documentation of any object in Python by just appending a question mark to the end of this object. And it works for any type of object. Functions, modules, built-in modules, third-party libraries, a variable that you just defined, anything. And if the docstring is not enough, you can append 2 question marks to see the complete source code of this object. I really like this feature because I no longer have to leave the terminal to search for the documentation. IPython also comes with a bunch of magic functions. Those are helper functions that start with 1 or 2 percentage signs, and you can use them, for example, to quickly measure the execution time of some code, run a file, browse the history of the previous IPython sessions, rerun some previous commands, or open a code editor to edit some code before executing it. And you can always write your own magic function if you want. If you think IPython is interesting and you want to learn more, check out the IPython documentation for a good overview of different features. If you prefer a more visual demonstration, I gave a presentation about IPython last year. It's a 45-minute long, fast-paced talk where I go through most of its features. Watching it on YouTube is probably better than seeing it live, as you can always stop and test a feature if you find it interesting. So I really recommend you that you start using IPython instead of the default Python REPL. Even if you don't care about most of its features, the tab completion, syntax highlighting, and automatic indentation alone will make your life much easier. And if you don't like IPython, there are some other Python REPLs out there. They don't have as many features as IPython, but they have different features. So maybe you'll prefer one of them. We have bpython with syntax highlighting, auto-completion, automatic indentation, and features like rewind that lets you remove the last command that you executed. And we also have ptpython with a similar set of features and a slightly more advanced interface with some menus, some Emacs key bindings, and stuff like that. Once you wrote some code, you want to make sure that it works. And I don't mean if it works now, because you just wrote it, you clicked stuff around, so you are sure that everything is fine. But you need to make sure that it will still work after someone else changes some other piece of code. So let's talk about writing tests. Python comes with a unit test modules that you can use for writing tests. It's very basic in terms of features, and at the same time, it's overcomplicated in terms of how many different assertions you have to remember. So I suggest that you learn PyTest instead. PyTest is probably the most popular Python library nowadays. It's packed with features, but at the same time, it stays very beginner friendly. You don't have to write classes that inherit from unit test case. You just write functions that starts with test. You don't have to memorize assert equal, assert true, assert in. All you have to do is to use assert something equals something else. And that's pretty much it. If you need something more advanced, PyTest has a lot of additional features and a very vast ecosystem of plugins. To start using PyTest, install it with pip. Don't use pipx. Different projects might use different PyTest configurations or different PyTest plugins. So you don't want to install a global version, you want to install PyTest in each of your projects. Once you install PyTest, create a tests directory in the root folder of your project. Create files starting with test underscore inside that folder, and then write functions that starts with test underscore inside those files. If you follow this advice, PyTest will work out of the box for you. Once you write some tests, go back to the terminal and run pytest command. PyTest will detect all the tests and run them for you. As you can see here, PyTest detected 4 tests. 3 of them in a file called testmath that I used when I was showing you how to run tests in VS Code, and 1 more in the testmath operations file. The last one has failed, and you can see a traceback and error message. So now you can go and fix this test. So that's how you can use PyTest. There are some other PyTest features or testing features in general that you'll probably need to use in your tests. So let's talk about them. First, fixtures. Let's use an example. Let's say you have an e-commerce website where you sell some stuff. You want to make sure that everything works fine because, well, you don't want to give your products for free if there is a bug. So you write some tests. You check if a user can log in, you add some products to the cart, you go through the checkout process. And for each test, you need to create a user. So instead of writing code that creates a new user inside of every test, you decide to extract this user creation to a separate function and then run this function at the beginning of each test. So actually this use case where you need a specific object to exist at the beginning of a test is such a common scenario that the idea of fixtures was born. A fixture is a function that returns an object. In our case, the user object, but it can be anything. It can be an item in your shop, it can be a database connection, and then you can use this fixture in your test. So to create a fixture in PyTest, all you have to do is to write a function and then decorate it with PyTest fixture command. If you don't know what a decorator is, don't worry, just put this piece of code over a function and it will turn it into a fixture. And then to use a fixture in your function, you need to pass this fixture as an argument to your function. And as a side note, if you want to have the same fixture in multiple files, just put this fixture inside a file called conftest.py. PyTest will automatically load all the fixtures from this file in all your tests. Next concept is mocking and monkey patching. So let's say that on your e-commerce website, you want to test that if a user buys something, first you charge his credit card, and if everything went fine, you send him his order. Well, you can't charge a real credit card each time you run tests. Okay, technically you can if you're very rich, but let's assume we are not very rich and we want to avoid losing money. So that's why you need a mock, a fake object that you can use in place of a real one. So instead of sending credit card details to Stripe, which is a very popular payment processor, you replace Stripe with a mock object. This mock object should return a success message if you provide it with correct parameters. The whole point of mocking is that it's not your job to test if Stripe works fine. All you need to do is to make sure that you send correct data to Stripe, and then that you accept and process whatever information comes back from Stripe. So let's say in our code we have a charge customer function that takes an amount of money and sends it to the Stripe through Stripe API. Back from the Stripe, we get a response, and the response has a status. We check if the status is equal to success, and then if it is, we set the status of the current order to processing. By the way, this is a completely dummy code that won't work with Stripe. It's here just for the illustration purpose. Then in our test payment function, we need to pass the monkey patch function. And then we use this monkey patch function to replace the charge attribute of the Stripe object with something that just returns a dictionary with status equals success. Then when the charge customer function is called and it gets to the point when it executes stripe.charge, it won't execute a real function. Our mock will kick in and it will automatically return the dictionary with the status equals success. That way, no information actually gets to Stripe, and we can assert that if Stripe returns success, the current order status is set to processing. All right, I have a joke for you. A tester walks into a bar. He orders a beer, he orders 0 beers, he orders 1 million beers, he orders a lizard, he orders -1 beers. Then a first customer walks into a bar, he asks where the bathroom is. The bar bursts into flames, killing everyone. So there is an important lesson in this old and moderately funny joke, and it's not about fire extinguisher or fire escapes. You probably want to test your functions with a lot of different inputs, and PyTest has a feature just for you. You can parameterize your test. So you have to decide which part of your test can change. In case of our e-commerce website, that could be the number of orders and the size of a single order. And then you write one test that accepts those changing parts as parameters, and you use pytest.mark parameterized decorator to pass different values to those parameters. If you look at this example, PyTest will actually turn this test into 4 different tests. In the first one, the number of orders and the order size will be equal to 1. Then in the second test, the number of orders will be equal to 100 and the order size will be equal to 1, then the vice versa, and then both of them will be equal to 50. PyTest parameterize can save you a lot of repetition when you write tests. One of the things that we usually forget to keep up to date is documentation. Mostly because we don't have a tool that tells us when it's outdated and no longer valid. PyTest can solve part of this problem. If you put some code examples in the documentation, it can evaluate them and tell you if they no longer work. Let's see an example. If we run PyTest with doctest modules parameter, it will check for parts of your documentation starting with this symbol. If there are any, PyTest will evaluate this line and see if the result is equal to the next line of the documentation. If it's not, it will report an error. Speaking of running PyTest with parameters, there are a lot of cool parameters that you can pass to PyTest. You can, for example, stop running tests after the first failure. You can rerun only the failed test from the previous run. You can select a single test or a single file to run. You can start a debugger when there is a failure, or you can run tests in parallel. You can mark tests, so assign a label to a test and then only run tests with a specific label. That way you can split your test into, for example, unit tests that you will run every time and end-to-end tests that you will run only on the continuous integration platform because they are slow. And you can also use one of the predefined marks. For example, you can tell PyTest to skip some tests if you know that they are broken and you don't have time to fix them today, but you still want your CI to work. You can tell PyTest that some tests are actually expected to fail. And you can skip some tests if a specific condition is true. For example, you might want to skip some tests if they are not supposed to work on Windows. The final piece of our how to make a good Python project puzzle is the documentation. At some point, you probably want to explain how to use your project or how someone can contribute to it. So you need to write a documentation. One of the most popular tools for Python is called Sphinx. It's easy to use and it comes with a lot of useful features out of the box. You can generate documentation in various formats. You can easily create hyperlinks between functions and modules. You can automatically generate documentation of your APIs. And similarly to what PyTest does, it can also test the code examples in the documentation. So to use Sphinx, install it with pip or pipx. I'm gonna go with pip because maybe in another project I want to use something else. Once you have Sphinx installed, run sphinx-quickstart command and pass the name of the folder where you want to keep your documentation. A common name for this folder is docs, so I'm gonna go with that. Then Sphinx will ask you a few questions about your project and generate the documentation. With Sphinx, you will be using restructured text to write documentation. It's very similar to Markdown, but it has some custom syntax on top of it. If you want to learn more, here is a link to some instruction how to use restructured text. If for some reason you don't like restructured text and you want to use Markdown, there is an extension called Recommon Mark that you can install. However, I will go with restructured text here. If we go to the docs directory, you will see that we have a make file and make bat. Those are files that we will use to generate the documentation. And then we have build and source folder, because we chose a separate source and build directories in the first question that Sphinx asked us. Inside the build folder, we'll find the generated documentation. Right now, we don't have any. Inside the source folder, we'll find the configuration file and index.rst. This is the main page of your documentation. As you can see, there is not much going on here, and VS Code is suggesting that it can help us with some extension to preview the RST files. Right now, I'm going to dismiss it. So to generate the documentation, we have to go to the folder that contains our make file and run make HTML command. This should generate the HTML version of the documentation. If we now go inside the build directory, you will see that we have HTML folder, and inside of it, we have some pages. Let's open the index.html in the browser. Great, so we have a skeleton of our documentation. There is not much going on here, so let's see how we can fill it up with some content. You can add more files and folders to the source directory, and then you can link them under the talk3 section to create additional pages of your documentation. Just make sure you are actually creating those 3 files that we are specifying here. Otherwise, you're gonna get some errors when building the documentation. If you're wondering what to actually put in your documentation, I can highly recommend you this talk and this blog post. If you use this framework for writing documentation, you will have 4 main categories. Tutorials that will explain a complete beginner how they can start using your application. How-to guides, so recipes how to solve a specific problem. Explanations, explaining how your project actually works. And reference, which is like a Wikipedia page for your project. One feature that I really like in Sphinx is that it can automatically generate the documentation for your API. All you need to do is to add a plugin. So open the conf.py file that contains the configuration for your Sphinx documentation. And then inside the extensions list, add sphinx.ext.autodoc. Next, we need to create a file that will contain this API documentation. So let's create a new file called api.rst. Inside this file, for every module that you want to document, you need to add the following code. First, the name of the module. Let's say I want to document the math operations. Okay, this part is completely optional, but I like to add it to have a nice headers for each of the modules. And now the mandatory part. Normally, you should first provide the name of the package and then the name of the module. Since here, I don't really have a package and I have only one file, so it's okay to skip the name of the package. But normally you would want to use packages to namespace your modules, so to easily separate them. Let's try to build our documentation. And we get an error. The problem here is that math operations file is above in the directory structure comparing to conf.py file. So all we have to do is to modify the path inside the conf.py file. So let's open it. And at the top of the conf file, you will see an explanation of this problem. So uncomment those lines and change this into 2 directories above. That's because we have conf.py file inside the source directory. Above, we have the docs directory, and the math operation is 1 directory above the docs. That's why we have to go up 2 directories. Once we save this file, let's try to run make again. And this time it's successful. Let's open this file in the browser, and here we have it. If you're wondering how do we get those parameters and the return value, that's because I modified the math operation and I added more stuff to the doc string. If you go to the Sphinx documentation, you can see how you can specify parameters and return values of your functions. One feature that I really like is to have a link from the documentation to the source code of the functions. And with Sphinx, we can enable it with just 1 plugin. So open the conf test and add Sphinx ext view code to the list of our extensions. Now build that documentation again. And if we go to the browser, you can see a link to the source of every function. It's a really nice feature, especially that we can get it by modifying just 1 line. If you're building a REST API, so for example, you are using Django or Flask only for the backend of your application, and then you have Vue or React in the front end, check out the Swagger UI and Redoc. They will both let you easily generate interactive documentation for your applications. When we talked about PyTest, I show you how you can test your documentation. But if you're not using PyTest, you can also test your documentation from Sphinx directly. First, you need to enable the doctest extension to make sure that you actually have some test in your documentation. And then finally run make doctest command. As you can see, the traceback is not as pretty as in PyTest. We don't have green and red colors, but you can see that our test has failed. I would normally stick to PyTest to run all types of tests, but maybe you like it that way. And final thing that I want to show you is read the docs. If you're working on an open source project, you can host your documentation for free online. All you have to do is visit the Read the Docs website and create an account here. Once you have an account, you will have access to a dashboard where you can connect your code repository. Read the Docs will take your Sphinx documentation and put it online. Here is an example how it can look like. So we've learned a lot, and now I would like you to put all that new knowledge into action. Let's write a small to-do application where you can use all the tools and ideas that you have learned today. Your to-do application should implement the following features. Show a list of tasks, add a new task, mark it as done, and delete a task. Apart from just writing the code, I would like you to also write some tests, document some of the functions, and generate documentation with Sphinx. I would also like you to install Flake 8 and Black and run your code through those tools. As a bonus point, you can configure VS Code to use Flake 8 and Black automatically. You can start this project from scratch, but I would like you to practice using cookiecutter templates. So I have created a template for you that you can use. Let me show you how you can start. And for this exercise, I will no longer use a clean macOS installation. I will use my normal work environment so you can see how I'm working. So let's start our project. Let's make a folder for our application. Let's check if I have cookiecutter installed globally. And yes, it's there, version 1.7, so it should be fine. So let's create a virtual environment. I'm using virtual fish, so I will be using different commands than I showed you. And something broke. Well, that's interesting. So it turns out I messed up something when I was switching Python versions, and virtual fish didn't like the 3.8, so I'm back to Python 3.6.2, and now it should work. So that's the correct log that you should see, not some scary shell errors. Did I mention how happy I am this is not live coding and I can actually go and fix some errors and you don't have to stare at me running random commands for half an hour? We should do this more often. So we have a folder, we have a virtual environment. Let's run the cookiecutter. Let me copy this. I got this message because I already downloaded it. Let's re-download it. Cookiecutter is going to ask you a couple of questions. Some of them are less important, some of them are more. That's my name, so I'm gonna stick to it. Project name, let's leave it as this. Description stays the same. Directory name, well, let's stay with 2. So here is the important part. I forgot to mention it so far, but I will be using Flask in this simple web application. If you select option 1, so scaffolding, cookiecutter will generate a pretty comprehensive scaffolding for your application. It will take care of setting up everything, the Flask app, the database with the models, fixtures for tests, and your task will be just to finish the function, add tests, and the documentation. If you don't know Flask, or if you haven't used it in a long time, or if you don't know web development in general, I suggest that you select this option. It's gonna be easier for you to finish this tutorial, but then you can just look around and see how I decided to implement it. If you select option 2, so empty files, cookiecutter will generate files that are mostly empty with a bunch of to-do comments. The main reason why I'm generating those files is to enforce some structure. A simple website in Flask can be written in a single file, but one of the main points of this exercise is to learn how to split your project into separate pieces. So let's go with option 2. And this option will generate the HTML scaffolding for you. I suggest you select yes. This will generate a simple HTML website with some bootstrap styling. If you choose no, you will have to write the HTML yourself, and this exercise is not really about writing HTML, but it's up to you. And finally, you can select a license. This is quite a common question in the cookiecutter templates. I'm gonna go with one. So if we look inside the current folder, you will see that we have a to-do folder created. If we move there, you can see that we have a few files. Let's actually open VS Code here. In the README file, you will see all the steps that you need to do to run this application. We already have a virtual environment, so you can skip the first 2 steps. Then inside the requirements.txt, you will see some requirements. We are using Flask, Flask SQL Alchemy, Sphinx, and PyTest. So then back to README, you can see that we have to install requirements first. So let's do that. And now we can finally try to run our application. But first, enable the development mode for auto reloading and more verbose errors. Keep in mind that you don't want to do this in production, but for development, that's a recommended option. And if we try to start the server, we're gonna get an error because run PI is empty. So here is where you start. You need to put some code here that will set up everything and run the web server. And then checking some other files, you can see that we have views. Here you should create some views and connect them to URLs. Then we have models. Here we should have a database model for our task. It should contain at least the body, so the text of the task, and done, which is a Boolean value defining if the task is done or not. Then we have an API. So instead of listing, creating, deleting, and finishing tasks inside the view functions, I would like you to write views file that will call functions from the API, and functions from the API will call functions from the models. In the templates, we have the HTML page for our application. There is a lot of code, but most of it is just bootstrap styling. You can see that our HTML template is expecting a tasks list, and then it will go through each task there and print a task. This task should have 2 attributes, done, to specify if the task is finished or not, and the body with the text of the task. Finally, we have some URLs that suggest you what URLs the views should expect. So we should use done/task ID to mark task as done and delete to mark task as delete. Also here we have a form to create a new task. It will send a payload with the text to /tasks URL. Then we have a test folder for our tests that's currently empty. And we don't have a test for documentation, so we'll have to generate it with Sphinx. Okay, so you can pause the video here and try to do this exercise. If you're starting from scratch, you can completely ignore my project structure and write it however you want. And if you decided to start with the scaffolding and you got stuck somewhere, don't worry. In a moment, I will show you how to write this project, writing code to match what we already have in the scaffolding. So please pause the video, try to write it on your own. If you got stuck and you want to take a look at the final solution, you can go to this GitHub URL. And if you want to see how I would do this exercise, go to the introduction URL and scroll video to 1 hour and 51 minutes. This is where I start building this application. However, I strongly suggest that you first try to build it on your own. Once you have built this application, you probably want to deploy it somewhere. So check out the deployment section. Here, I explain how to build a very simple Docker image. It's far from perfect, but it's good enough to put your application on the internet. A good place to practice deploying your application is a playwithdocker.com website. It's a simple playground where you can deploy your Docker image. Of course, you won't get a proper URL and your application will disappear after 4 hours, but it's free, so it's a good place to practice. So this is where we finish this tutorial. I hope you enjoyed it, and I hope we actually got to the end without any technical difficulties. So if you are watching this video, it means that now it's time for the final questions. So let's switch back to the live session.
That was really interesting, Sebastian. And you've been busy in the chat too.
Yeah, I was trying to answer all the questions, and I think I kind of did.
Yeah? Are there any questions you would like to repeat here?
Yeah, so I noticed 2 questions that might be interesting for wider audience. I think people had some issues figuring out what's the difference between the pyenv, the virtual environment, and PEP8 that I mentioned as in the first part. So basically, pyenv is a tool that you would use to install different versions of Python. So if you need Python 2.7 and then Python 3.9, you can use pyenv for that. Then if you start working on a project and you need to install Python packages, let's say for one project and different packages for another project, you would use virtual environment or one of the tools like virtual nwrapper to manage those dependencies. And then finally, PEP8 is a tool that you can use to install packages globally. It will manage a virtual environment for you. So you don't have to do anything. If you want to have a package, let's say a black to format your code, or the cookie cutter that I just showed you, then you would use PEP8 and it installs this package globally. You don't need this package for a folder. You want to have this tool on your computer, but at the same time, you don't want to mess the dependencies of this cookie cutter global with some of your project dependencies. And one thing to keep in mind is that if you install different versions of the same package using PEP8, so globally, and inside the folder using virtual environment, if you're inside this virtual environment, the package installed from the virtual environment is going to take the precedence. So you're going to use this one. And if you're not inside the virtual environment, then you're going to use this global package.
Great. What would you say are the most common pitfalls when setting up your environment?
From personal experience, that would be updating the system Python version, because then you have to reinstall a lot of stuff on your computer. But I would say figuring out how to not mess Python versions and dependencies between projects and things like that. So those three tools that I mentioned are really great for that, because they modify your path environment variable. So you're not really installing anything as a root. You're just installing stuff in a separate folders. You prepend those folders inside your environment variable path, and then your computer is going to use it. So if you use those tools, everything is nicely separated. For example, from my personal experience, I see that when I'm installing packages with Homebrew sometimes installs some weird Python version in the background, but I don't really care because I'm using pyenv. So this Homebrew version installed somewhere there, it's not even being used by me.
Okay. Right. Thank you. And thank you for a really interesting workshop. And
thank you for having me.
Thank you. Let's have lunch, and the conference will continue in the afternoon.
Enjoy the conference.
Bye.